This area is the World Biosphere Reserve, but it's also heavily impacted because just behind me there's a road going along there, and so there's nutrients and there's chemicals that are coming into here and impacting the ecosystem. And this is a fairly healthy ecosystem, and there's a large variety of species that occur here. Most of these are marsh species, so it's very shallow soil, and it's got a very high groundwater here. And we're getting a whole variety of wildflowers and different sedges and rushes and bulrushes. And so this is a very rich and healthy ecosystem. But there are challenges here. There's been a lot of disturbance, and so the ecosystem has shifted, and things like purple loosestrife and Phragmites have invaded these areas, and there's large swaths of Phragmites out here, and that reduces, because it's a non-native species, it reduces the amount of native species in the area. It grows really fast and tall, and so it actually smothers all the other species, and it's rhizomatous, so it very quickly spreads into these natural areas. And as you can see, most of the native species here are fairly low, and so when you get something that's really big like Phragmites invading, then it smothers, it takes up all the light and smothers all the native vegetation. And one of the things that you can do to help restore this ecosystem is periodic burning. So taking off that biomass from the Phragmites. You can also, because Phragmites needs it grows really fast, so it needs a lot of oxygen in its root system. So in the late fall, you can actually chop down the Phragmites in the patches where it's occurring here and there. If you cut it right down low, and so when the water floods up in the winter time, in the fall the water is way down in the early fall, and you can go in and cut it. But then in the winter, the water level is rising up, and if the stem is not above the water, then it can't get oxygen down to its root system, and you can kill the Phragmites. So repeatedly cutting the Phragmites and allowing this flooding to occur will naturally kill the Phragmites. Other people use chemicals, but there are alternative ways to reduce this species. You can smother it by cutting the Phragmites and just dropping the biomass on top of itself so that it smothers it and reduces its viability by cutting it at a time when it needs that energy to produce seed. It doesn't actually produce a lot of viable seed because it's not native to this area, and so it doesn't have those interactions, but the seed that it produces do cause problems. Mostly it's reproducing by vegetative means and spreading through the ecosystem by vegetative propagation, and you get vehicles and boats and different things like that cutting up the Phragmites roots and then spreading them around, and so it's taken over large areas of different really wonderful ecosystems. And these ecosystems have all sorts of different creatures that use them. They're on a major migration route for ducks and birds, and they're just funneling through this area, and on their way south when it's in the fall, and in the spring they're coming all from the south and then funneling up into the north. So having these really rich habitats with lots of seeds and lots of tubers is really essential for this migration process, and fattening up the birds on the way south and giving them a source of food when they come back in the spring. In this area you can see a transition from an upland area into a wet meadow, moisture area, and then you have your emergent zone here, and then you have your aquatic zone, so your deeper water species. This is a low water year, and so you're seeing a lot of mud flat that's being exposed. But down here you can see your yellow water lily, and you've got your arrowhead species Sagittaria, and then as you come up the shore you have things like the bulrushes, and you have cattails, and a little further up the shore in this zone here, you're seeing things like rice cutgrass, sedges, rushes, and a lot of different wildflower species that are occurring that like to have wet feet. And so you get these different zones happening, and within a short distance you have a whole variety of different species that occur that each have their own very specific habitat requirements, their different moisture requirements. Some species can withstand being submerged completely, other species need to have oxygen pumped down to the roots, and other species are up on the shore where there's lots of moisture and they can grow rapidly, but they also in a bit more oxygenated zone. So having these different ecotones and these transition zones is really important for wetland ecosystems to have increased biodiversity, and you can change the biodiversity of an area by changing the slope and the different aspects. In a larger pond, wave action in different areas influences where these species will be. The depth of the water influences, I talked about light attenuation, so certain species can only go down to a certain depth, and then beyond that, there you don't get a lot of vegetation. So there's so many different species that utilize a wetland ecosystem. Land birds, they come here, they take a drink of water, and then you have all this whole suite of wetland species that are specific for these aquatic ecosystems. You've got your frogs, you've got your herons, all these different species that they're occurring here, and they don't occur on the dry land. So mixing it up, you can even in different areas, when you have a dry land area and you know that your groundwater is fairly high in that area, either that or you're near a stream, you can create little divots in the landscape, move the soil around, and allow for this pooling. Either if you're on a clay area, you can allow pooling, but if you're in an area with high groundwater, you can dig down and find that groundwater layer and create these wetland ecosystems. Because once you have that different mosaic within your ecosystem, you're allowing for more biodiversity to occur. And having water on your land is really important for the survival of all the species that occur there. So this is purple loosestrife, and it's another invasive species in aquatic ecosystems in North America, and it was a major problem for a long time. It's still a problem, and it was taking over all sorts of wetlands. You could see in different areas where the whole area was purple with purple loosestrife. But it used to be up about this tall, but now they've introduced a beetle from where it originated, and this beetle is actually starting to reduce the population down to a more manageable level, so that it's not an entire area covered with purple loosestrife, but now it's more a bit of purple loosestrife here and a bit of purple loosestrife there. So this beetle actually eats the leaves, and it reduces the viability of the plant, and so it's making the plant shorter, and it's also reducing the amount of seed that the plant can produce. So it's basically the beetles are taking a lot of the energy away from the purple loosestrife, whereas originally when this exotic species arrived here, and it's true for most exotic species, they have no predators when they first arrive, and none of the native species recognize it as a food, and so they can go crazy because you're using all the nutrients that they can gather. And a lot of times these invasive species are bigger than they are in their home country, and it makes it much more difficult because they're so vigorous and growing so fast and spreading so fast. And then in Europe, where this species is native, it's actually a small plant, but because it has all the native predators in Europe that are controlling it, and it's not a monoculture in those ecosystems, it's just a normal wildflower that occurs there. He introduced it to Canada and through the horticultural industry, and it spread like crazy because there's no competition for it and no predators to reduce its viability.
Thank you for watching. If you found this video helpful, please consider supporting us on Patreon. Your support keeps these videos free for everyone.